So this is unit 4, the beginning of unit 4. We're doing inverse trig functions. So basically what we're doing is taking trig identities and using them to find the inverse, and it's going back and forth between points on a unit circle and radians on a unit circle. So we only go back and forth. So we're going to show you how that works. There we go. All right, so we're doing cosine, then sine, then tangent. So the inverse cosine is first. So in order to understand why this works the way it is, you first have to look at the graph. When we're looking for the values that you can work for inverse cosine, you look at the graph because you can have points on the graph that repeat themselves. So here's the graph for cosine. If we start up here, where did my point go? And it goes down, and then up. Sorry about the weird pen. Okay, for the graph for cosine, as it goes starting at 0, which is here, and it goes till pi down here, before it goes back up again and repeats the y values. Well, we only want these values that don't repeat the y values, so from 0 to pi. So our domain of what we're looking at for these inverse cosine functions is going to be just the top of the unit circle from 0 to pi. Okay, notice they're brackets because you can include 0 and pi in your answers to find these values. It's going to come up later as a problem for tangent, but we'll get to tangent when we get to tangent. Okay, so you can only do the parts before they start repeating themselves, which is why we can only use from 0 to pi. After pi, the y values of this graph start repeating themselves, and we can't have that. Okay, so let's look at how this works. Again, we're only looking at the top half of the unit circle from 0 to pi. So we're going to look at the value inside the parentheses is going to be the part of the point, and we have to find the radian for that point. So if you remember that cosine is x, so we're looking at the values on x, on the points, all right, to find out what radian would go along with that. So this is the coordinate 1. So what x value on your unit circle would give you 1? And that would be at 0 pi. And that would be your answer, and that's it. Let's try another one. Okay. So again, all right, you're looking at your unit circle. Where would you find the x value be root 3 over 2? And it has to only be on the top half of the unit circle. It can't be anywhere else. And the x value is root 3 over 2 at pi over 6. Okay. So some of you might be saying, well, the x value is root 3 over 2 at 11 pi over 6. 11 pi over 6 is not in the top half of the unit circle, so we don't use that one. We're just using between 0 and pi in the unit circle. And then the last one for cosine we're going to use in the notes is negative 1/2. So we're looking at the unit circle at the x values at negative 1/2, and that is 2 pi over 3. Okay, so that is inverse cosine. Next, we're going to look at the inverse sine. So for inverse sine, if we draw the graph again to kind of highlight how this works. All right, here's your sine function. Okay, and we're looking for, at the beginning of the graph, it goes up, but by the time it hits the first peak of the graph, here at pi over 2, we have a problem. The problem is, as it goes down, the y values in the graph start repeating themselves. So how do we fix this? What we're going to do to fix it is we're going to go backwards. If we go backwards in our graph, and we go down, right? And then what happens is that as you go backwards, we hit negative pi over 2. Here's negative pi over 2. And now none of the values are repeating themselves on the y terms. Okay, so we're looking at this section of the graph. Okay, so that makes sense now when we're looking at our unit circle. We're looking from negative pi over 2 to positive pi over 2, which is just the right-hand side of the unit circle. Okay, again, notice that the domain is in brackets. You can use the values at negative pi over 2 and positive pi over 2, just like you could use the values of 0 and pi for inverse cosine. All right, so let's try some examples. All right, so looking at the right side of the unit circle, we're trying to find out what y values are going to be 1. All right, there's only one y value at 1, and that is positive pi over 2. Okay. Next, we got inverse sine of negative root 3 over 2. So again, we're looking at the right side of the unit circle. The only time where the y value is negative root 3 over 2 is going to be at negative pi over 3. Now notice it's negative pi over 3, not 5 pi over 3. You can't go around the unit circle. To get there, you have to go backwards. All right, and the last sine one is going to be at negative root 2 over 2. Again, you're going backwards to get into negative root 2 over 2, which is again in the fourth quadrant. You're going to give negative pi over 4. Okay. All right, last inverse we're going to be using is the tangent function. For tangent, if we look at the graph again to understand the limitations on the domain, the tangent function looks like this. Okay, and it's from negative pi over 2 to positive pi over 2. Okay, which is a normal tangent graph anyway. There you go. All right. Now, again, you're using just the right side of the unit circle, but if you'll notice in this case, the domain is in parentheses and not in brackets, because if you have a tangent function at positive pi over 2 or negative pi over 2, it's undefined, so you can't actually use those values. And it wouldn't make sense anyway, because we wouldn't ask you to find the inverse of an undefined. It doesn't make sense. You can't have an undefined anything. Okay. So some examples for tangent. Okay. You have tangent of negative 1. So where does the y divided by x, because that's what tangent is, where does that give you negative 1? So that's going to be at negative root 2 over 2 divided by positive root 2 over 2, which is at negative pi over 4. Okay, because again, you're going backwards, not around the unit circle. You're going backwards to get there. Next one, where's tangent going to be 0? So where does y divided by x give you 0? So you have 0 divided by 1 gives you 0, and that is at 0 pi. Oh, that was a little fast. Sorry. And the last one for tangent is where's tangent going to be positive 1? All right, similar to the first tangent example we had, it's going to be positive. It's going to be root 2 over 2 divided by positive root 2 over 2 again, which will be positive equal positive 1, and that's going to be a positive pi over 4. Okay. Now with these inverses, we can combine them with just regular functions, trig functions, to go back and forth between points and radians on the unit circle. So that's what the first two examples of this are. After these two, please try the rest of these examples and then do the practice sheet. If you have questions, please email me or contact me. All right, so how these work. You're going to do the inside part first and work out from there. Okay, so the inside, you can do the inverse cosine of root 3 over 2. So because it's an inverse, now you're restricted on which domain to use. So for inverse cosine, you're using the top half of the unit circle. All right, and that's going to give you x is root 3 over 2 at pi over 6. So you're going to replace the inverse cosine of root 3 over 2 with just a pi over 6. Then you're going to rewrite the sine next to it. Okay, next you find what the sine of pi over 6 is. So again, we're looking at pi over 6 on the unit circle, at the radians, and then finding, since it's sine, what the y value is. And the y value of pi over 6 is 1/2. Okay, so that's all you're going to do. Now, you can string a bunch of these together, which is going to happen in some of the other examples, but you just go inside and work your way out. So it's going to be flipping back and forth between finding the inverse and finding the regular function. Okay. So this is the opposite. So this time what you have is you're given a radian. You got to find the inverse tangent, regular tangent of pi. You're going to find out what the value of the points are at pi for tangent. So you look at pi for tangent, you have 0, which is y, divided by negative 1. So 0 divided by negative 1 is going to be 0. Okay, and that's going to be a radian. Okay. No, that's a point. My apologies. I got confused there a second. So that's a point. So tangent of pi is just going to be 0. It's not 0 radians, it's just 0. Okay, so now what we're looking for is we have to take a point of 0 in the x term and find out what radian belongs to that for cosine. So find on the unit circle where x is going to be 0, what radian that is, and that's going to be pi over 2. Okay. Again, it can only be in the top half of the unit circle because we're dealing with inverse cosine. And from there, please try the other examples, and then please try the practice sheet. All right? And hopefully everything good works out.